Alright guys, so this will be section 10.6 here. It's going to cover the writing the equation of a circle, like if you actually wanted to graph a circle. But before we get into that, let's just do a quick little review of the last section, which was the lengths of segments inside circles. So a little complicated diagram here, but see if you can figure out a way to find x and y. Okay, so maybe pause the video and use some of the properties from the last section. Alright, so let's see if we remember that. Let's take a little look back in the review here. What I'm noticing, first off, we can find x or y first, it doesn't really matter, but what I'm noticing is this segment right here, along with this segment. Remember, if you have two chords and they intersect inside the circle, the one property says that piece times piece, so meaning 16 times y, must equal the other segment's piece times piece, right? So 14 times 8. So 16 times y equals 14 times 8. If we do a little bit of algebra on that, just multiplying the 14 times 8 is 112. And then we can divide both sides by 16 and we can solve and get y equals 7. Okay, so that was one of the rules. And now to get x, we're going to have to use something else. Let's see what's going on with segment X. Let's use a different color here. Okay, segment X is part of this secant. And there was a rule, if I use that along with this secant, one of the rules said that the outer piece times the entire piece of one secant must equal the outside piece times the entire length of the other secant. So for our example, we could do something like the outside piece, one of them is 24. Now that entire segment, looking at DH, the entire segment is 24 plus whatever x is. And then with the other secant, the one up top there, the outside length is 25. And the entire length of that segment is the 25 plus the 20, okay, or 45. So that should give us an equation that we can solve for x. So if we go ahead and distribute that first 24, 24 times 24, 576, plus 24x. 25 times 45 is 1125. And now we can just subtract the 576 from both sides. Let's see, what is that, 549. And then finally, when we divide both sides by 24, we're going to get our final answer of x equaling 22.875. Okay, so just remember those were the rules. Basically, if you have chords intersecting inside the circle, like the first example, like we had this and this, it's always piece times piece equals piece times piece. But the ones that intersect outside, the secants, it's always outside length times entire length equals outside length times entire length. Okay, all right. Okay, so moving along, let's say again, we've graphed lines, and in algebra you guys probably graphed parabolas, quadratic functions and things like that, and there's a whole bunch of other ones that you'll get to in Algebra 2 and beyond. You ever think about what would the equation be if you wanted your graph to be a circle? Okay, it's kind of a weird thing. It's definitely different. It's not just a straight y equals something like other functions are, although it could be written that way, but it's a little more complicated. But it actually goes back to the distance formula. And the idea with the circle, so all circles have a center, right, and then a radius, as you can see there. And what a circle actually is, like, the definition of a circle, if you think about it, it is the set of all points that are the same distance from the center. Okay, so let's say the radius is 5 or something. So you plot your center, radius is 5 units. If you were to plot every single point that was 5 units away, it would compose of that entire circle. Okay, so basically the distance from, we call the center of the circle HK, just because it's like a special point. We're going to use H and K in our formula in a minute. And then xy over here, this is just any old point on the circle. Okay, any point on the circle can be xy. The key is that that distance again between hk and xy always remains constant, and that distance is equal to whatever the radius of the circle is. Okay, so if you remember the distance formula, it's just going to be x minus h squared plus y minus k squared. Okay, remember we would do x1 minus x2 squared, and y2 minus y1 squared, and then add them up and square root it to become the distance formula a long time ago. It's basically the Pythagorean theorem, just kind of solved for the hypotenuse, if you want to think of it that way. But that's just distance formula, right? Now the way you're going to see the equation of a circle written, all we're going to do is we're going to square both sides of this and get rid of the square root. Okay, so it's going to look like this. Here's going to be the equation of a circle that we're going to use. X minus h squared plus y minus k squared. And if we square, we squared the left side to get rid of the square root. We need to square the side with r on it, so the r will become r squared. Okay, and that's what we're going to use. That's going to be the standard form for a circle. And it's going to be the most common form that we use. There are other ways to do it where you could kind of like multiply things out or whatever that you might get into. But for now, that's how it's going to look. And all you need to remember again, the important pieces are that the center of the circle is going to be some x and y value, but they're special. They're h and k. You'll see them right there. And then, of course, r is the radius. So just notice when you write the equation, it does have r squared. So that's one little common mistake if you're rushing. Once we start doing these, you'll see what I mean. But make sure you're always squaring the radius when you're writing the equation. Okay, so let's get into a couple examples where it really helps to see it with some specific numbers. But I just wanted to make that connection. It really is just the distance formula kind of solved and using r instead of d because that distance is the radius. Okay, so let's do a few specific problems. All right, so let's do both things. Let's graph an equation. They give us the equation. Let's see if we can figure out what the circle itself is going to look like here. Okay, so the equation is x minus 2 squared plus y plus 3 squared equals 9. Okay, and if we remember again the standard form, the way we're going to always write it is x minus h squared plus y minus k squared equals r squared. Okay, so we can kind of line things up. You can see your h and your k, again, the center of the circle are there and there. And then the radius squared in this case is 9, okay? So here's kind of the trick. So the radius of the circle, if r squared is 9, right? You take the square root, the radius of our circle is going to be 3. Okay, so that's how large the circle is going to be. Now, since the form we're using is x minus h and y minus k, when I look, it's a little confusing and it might seem a little backwards, but see, this is already x minus something, right? So h is actually 2. Okay, our equation is x minus 2. But with the y value in there, ours has a plus in there. So to make it a minus, k would actually need to be negative 3, right? To be y minus negative 3 would make it the plus. Okay, so that's a little backwards, but here's the little trick, and you can kind of avoid that. If you just have in your mind, okay, if you look at this equation, okay, again, our equation is x minus 2. Let me just clear it up here. Just kind of think everything's the opposite. Okay, meaning when you need the center of the circle, okay, which obviously is very important, you're looking at, okay, the x-coordinate, it's x minus 2 in there. The x-coordinate's actually positive 2. Okay, the y has a plus 3. The y-coordinate is actually negative 3. It's always the opposite. And again, that's due to the fact that the standard form has these minuses built in. Okay, so if you just think of it again, opposite, opposite, and then know that that's r squared, you can plot this circle. So here's what it's going to end up looking like. We're going to make our center, okay, at positive 2, negative 3. Let me do my best to plot that on here. Okay, there's the center, right? Positive 2, negative 3, and the radius is 3 units. Okay, so from the center, I'm going to I'm just going to plot a point to the right, 3 units, 1, 2, 3. There's a point on the circle. Okay, going back to the center, up 3 units. There's a point on the circle. To the left, 1, 2, 3 units, and then down 1, 2, 3 units. Okay, and then we just kind of do our best. There's our circle. Okay, the center was at 2, -3. The radius of the circle, right? Visualize the radius from there to there is 3 units. Okay, and that's it. There's our circle. Okay, one good thing you can do too, if you have the Desmos app or on your laptop or whatever, you can type these in Desmos just like this. It does not have to be y equals like it does on your graphing calculator. And that's a way to check them and just kind of make sure until you really get the feel for them. Okay, but let's try one more. Okay, so give this one a shot here on your own. Think about where is the center and what is the radius, and then once you know those two things, you can sketch the circle. Okay, so look at it for 1 second, pause the video, see what you come up with. Okay, so for the center, again, let's start looking in here. Again, I'm thinking the opposite of what I see in the equation. The center is actually going to be a -2 for x, -5 for y. Okay, that's going to be your h and your k. Okay, so -2, -5. There's the center of this circle. Okay, just think opposites. It's the way a lot of things work when you're graphing functions. It's called transformations, and basically, and the idea, one thing to remember, anything like inside the function has an inverse effect. You'll kind of hear a lot of that in Algebra 2 and Pre-Calc. Same thing here. Okay, +2 really means -2, +5 really means -5. Now the radius, okay, if we notice this equation over here is equal to 16, just remember that is r squared. So the actual radius is the square root of that, or 4. So that's how big we need to make the circle. So from the center, I'm just going 1, 2, 3, 4 to the right, 1, 2, 3, 4 up, 1, 2, 3, 4 to the left, and we're going to run out of room here, 1, 2. Okay, there's our circle, centered at -2, -5 with a radius of 4. Okay, and that's all there is to graphing these things. You could be asked, I may ask you, let's suppose I gave you the graph, okay, and I said, can you get the equation? So what you would have to do is just kind of work backwards and say, all right, where's the center? Okay, that finds me this. Then you can work back and know that it's going to have to be opposites again. So the -2 is going to become x + 2. The -5 is going to make it y + 5. And just count out the radius. The radius is 4, and then if you had to write the equation, you just need to write it squared as 16. Okay, so let's do one more example where we have to do a little more work. All right, so can we find the equation of the circle with a center at 3, -1, and this time they're telling us a point that the circle goes through. Okay, so let's think about, again, we know the form of a circle is always the same, x - h squared plus y - k squared equals r squared. Okay, so let's see what we can come up with. They're giving us the center. Okay, there's our h and our k, so that's good. We know h, we know k, but we don't know the radius of the circle yet. Okay, this time we just know a point on the circle. So just a quick little visual, if we want to, sometimes it helps just to have a rough sketch. So, and this is not going to be accurate at all, especially drawing this on an iPad or whatever, but this is just an idea to help us see what we're doing. So the center is 3, -1. Okay, 3, -1. And it goes through the point 3, 3. 1, 2, 3. So like this, right? Okay, and the circle does something like, I don't know, something like that, or whatever, right? Roughly. Okay, so terrible drawing, but you get the idea. Okay, so in this case, we know h and k, right? We know the center. So I know it's x minus h is 3. The y coordinate is really -1, so the equation is going to show a +1, right? Now we just need to figure out the radius so that I can put the radius squared in there, right? So in this case, we need to find the distance from the center to the point they gave us. Okay, so we're going to use the distance formula to find that. So the radius is going to equal the distance between these 2 points. Okay, so I'm going to do the old x I'm going to do the square root of the difference in the x values squared plus the difference in their y values squared, right? The distance formula using these two ordered pairs. And this is going to give me the radius of the circle, because that's what radius means, right? The radius is the distance from the center to any point on the circle, right? That's why we're doing this. Okay, so the 3 minus 3 is a nice 0. Negative 1 take away 3 more would be negative 4. Okay, so it's the square root 0. Squared is still 0. So negative 4 squared is 16. And the square root of 16 is 4. Okay, so that is going to be the radius, right? That's the radius. So to finish our equation, I just need to put r squared right there, right? So our equation, our final answer, we knew it was x minus 3 squared plus y plus 1 squared. Now if the radius is 4, r squared in the equation needs to be 16. So don't put 4 there. It's always the r squared value. Okay, and that would be the equation of a circle that would meet these conditions. And I did graph it. I'll just show you. This is a screenshot from Desmos here. It just verifies that it's right. So there was the equation that we got. You can see right over here. And you can see the center is at 3, negative 1. You can just kind of verify that that's the center of the circle. Here's the point 33 that they told us was on the circle. Right there. Okay, so this shows you, again, you can just type it in just like that in Desmos. You can check your answers. It gives you a nice looking graph. Pretty simple. Okay, so hopefully that helps. And that is the equation of a circle.